In this video, I'm going to show you how I built an AI-powered personal trainer that counts your push-ups and scores how good your form is. Before I get started, I want to give a huge shout out to my friend Ayush Pai. He had this amazing AI-powered basketball referee. Go check that video out. He was a huge help in getting this technology set up and really inspired me to get this project done. Pose estimation is the main technology driving this project. Pose estimation is a technique where a computer looks at an image and detects if a person is there, and then tries to estimate where it thinks that the body key point positions are. For example, these key points could be shoulders, knees, elbows, toes, and then it outputs that with a probability of how certain it thinks that guess is. For this project, I chose to go with the Ultralytics YOLO V8 model. This model is great because not only is it free, but it's really great for real-time applications. YOLO stands for You Only Look Once, which means that this can process real-time video feed. The first thing I did was get the model imported and initialized with all the key point names, and then get it into a very basic loop using OpenCV to capture images from the webcam. Here you can see my first demo of having the pose estimation work through the webcam in real time. Although there are plenty of other exercises I could have gone with, for this project I wanted to do push-ups. Push-ups are probably the most widely used bodyweight exercise. They're very simple, but they also require you to have good form. I have 4 objectives for this project. The first is that the video can be processed in real time. The second is that for each frame, I can detect how straight the back is. Third is that I can detect when the rep begins and ends. And then fourth is that all the information will be overlaid on the video feed. In order to measure back straightness, I'm going to apply a linear regression to the key points of the shoulder, the hip, and the ankle. With these points, we can construct a line and give a score that kind of represents how straight the user's back is and how well their form is throughout the movement. This also serves double duty because this linear regression line is a great way of measuring what their position is, which will be useful when we count reps. My first approach to detecting reps was to use something called the second derivative test. This requires you to take the derivative of a function twice, and because this data was coming in real time, I had to use a method of approximating the derivative, essentially using a slope calculation for the last and the current point. Due to this cycle, I had too much error and it proved infeasible. Here you can see the graph of the blue line representing the raw data, the orange graph representing the smooth function, and then you can see the red and the green line being the first and second derivative taken numerically from the smooth data. My next approach to detecting peaks in the data was to turn to SciPy. SciPy is a really extensive library full of tools for processing data, great for scientists and engineers. In particular, I used the SciPy signal find peaks function. This is a really simple function that has a ton of parameters, and so after a little bit of adjusting, I was able to get it to perform how I needed. Here you can see the algorithm working in real time. In blue, you see the raw slope data, and in orange, you see the exponential moving average filter that I applied. Each time the algorithm detects a peak, it'll draw that vertical red line, which is a great way to kind of visualize in real time how it's interpreting and reading the data. Now that the program works reliably for the sample data, I want to give it test cases and see if it breaks down. In this clip, you can see that the program is doing a decent job counting reps and recognizing where his position is, even though the background is completely different. In this video, you can see that the program is having trouble with the 2 individuals. When I initially designed this, I only intended to have one person in frame, and so having the 2 poses estimated really throws off the code. This is something I'd have to address in a future version. In conclusion, I'm very happy with how this project turned out. It's been my first dive into computer vision and pose estimation, and I've learned a ton of Python thanks to that. In the future, I could see this being applied to much more complex exercises like the squat or the deadlift that are much higher risk and also require a more precise kind of measure of what good form is. but the same pose estimation could be applied to those. Thank you for watching. The GitHub page with the full code will be linked in the description below.